In this video, we will spend some time on the internal working of HashSet. The source that you see on the screen is from JDK 19 source code, and this is the source code of HashSet class which is there in the JDK 19. So if you see, the HashSet class basically has a private and transient instance variable of type hashMap. It internally has a hashMap. When we create a new instance of HashSet by calling the default constructor, what it does, it simply initializes the internal hash map. So when we create a new object of HashSet, it internally creates a new object of hash map. After that, whatever operations we do on the HashSet, it simply delegates the responsibility or the heavy lifting to the internal hash map. These are parameterized constructors where we can pass the collection or initial capacity and load factor. Basically, these are related to hash map. We will cover these concepts when we learn about hash map. But whatever constructor we are calling, in the end, it will initialize, it will create a new hash map, and it will do all the operations on that hash map. So that's why the internal working of HashSet is actually pretty simple if you think about it, because everything is done by the hash map. So in order to understand the internal working, we'll have to understand the internal working of hash map, which we will do later. In this video, we will simply focus on the HashSet. Now, after the constructors, if you see the iterator, it simply returns the iterator on the key set of that map. So map is basically a data structure, a key value data structure. It has a key and a corresponding value. When we call the iterator on the hash set, it simply returns the iterator on the collection of keys, because if you call the key set on the hash map, key set method on the hash map, it will return a collection of keys. And because it is a collection of keys, so it has its own iterator to iterate over the collection of keys to get the keys one by one. So when we call the iterator on the set, it simply returns the iterator on the map keys. Okay. The set of the size is simply the size of map. And to check if the set is empty, it simply delegates the call to map.isEmpty. So if you see that everything is done on the map itself. To check contains, it internally calls map.contains key. When we add the value to the set, it internally calls map.put. So when we add a new value to the set, that value will be added to the internal hash map. In the method, it is calling map.put, then passing the value as key, and the value is this present. Let's see what this present is. If we see, the present is basically a final variable, a final value object kind. So it's a dummy value. The command says dummy value to associate with an object in the backing map. Because set has only a single value, it does not have that key value structure. So everything that we are adding to the set, that value is passed as the key to the internal hash map. And because hash map requires a value for that key and set doesn't have a value, so what we do, we pass a dummy value. We pass a dummy object as the value for all the keys. So all the keys in the hash map, in the internal hash map, they have the same value, this dummy object. So every time when we add a new value to the set, that value will be passed down to hash map as key, and the value of that map will be this dummy object. Now, one interesting thing with this dummy object is you may think that, okay, if we have to add the dummy value, then why a dummy object? Why not put the null to save some space basically? The thing with map.put operation is, if we open the documentation of map.put, then it says it returns the previous value associated with key or null if there was no mapping for key. So it means when you try to add a new key or a new entry to the map, now if this key does not exist in the map, in that case it will add the entry, it will add the key value pair in the map, and the map will return the null. That means it is a new entry. But if we try to put a duplicate entry, then it will check if that key already exists in the map or not. If it exists, what it will do, it will override or replace the entry, but it will also return the old value. Now think about it. If we pass a null value here, then when we call map.put and this map.put will return null, in that case we don't know if this key does not exist, that's why map returned null, or this is a valid null value that was added as part of this map.put call. I hope you are getting my point. To differentiate between two null values or two different meanings of the null values, if we are putting a null value, then we'll have to add an additional contains check that if map.contains this value, then do not add the value. So what they do, they use a dummy object. In that case, if the map returns null, then we know it is the first key. There is no duplicate. That is the only possibility, because for everything else, the value returned will be present if the key already exists in the hash set or in the internal hash map. All right. So that is more or less on the hash set. It simply does everything on the internal hash map. Now, coming to the linked hash set, which maintains the insertion order, that is even more simple. So if we open the source code of linked hash set, then we see it extends hash set. It is a child of hash set class. And if you see the source code of the linked hash set, what it does, so if you see the constructor of the linked hash set, what it does, it calls the super constructor, which is the constructor of hash set class. So if you go to this constructor, we see the map has been changed. This time we are creating a linked hash map. And that's it. Everything else is done on the internal map, which in this case is linked hash map. So in summary, when we initialize a new hash set, it internally creates a new hash map. But when we create a new object of linked hash set, it internally creates a new object of linked hash map. That's the only difference. All right. So that's pretty much it on the set. It was a small one. All right.